Alright, this is CE570, the video solution for problem number 70, done by group 18. Our given information is a thin square plate of dimension pi and thickness t subjected to the following deformation. You can see the image given in the book. And the constant beta is very small compared to 1. It describes the motion. We are asked to find the strain tensor associated with the map, and we can neglect all terms of beta squared order or higher, and then we need to find where the strain is the greatest, and then lastly sketch the deformed shape of the plate. So for the first part, computing the strain tensor, we can divide up into the three different components, x1, x2, and x3 as shown. Next, we can compute the gradient of the deformation map and find f in that way. Next, we compute the green deformation tensor, which is the f tensor transpose times f, and it yields the following matrix. Now, as it said in the problem statement, that we could disregard terms of beta squared or higher, and as you can see, as highlighted in red are all the beta squared terms, which we can now make 0, and so our deformation tensor has been simplified to the following tensor. Next, we are going to find the Lagrangian strain tensor, which is E equals 1/2 of our deformation tensor minus the identity matrix. And in doing so, all the 1's are canceled out of our matrix, and then our strain tensor is simplified to having just a term in the first row of the first column as beta z3 sine z1. And using this, we can find where the strain is the greatest, and looking at the term, we have to maximize the sine term as well as z3, and therefore the maximum strain value occurs at pi over 2, which will yield sine of pi over 2 equals 1, and when z3 is equal to t. Lastly, we were asked to sketch the deformed shape, and here are some coordinates and the value and different values, how you could map it. Here we have our original shape in the dotted lines in the deformed configuration in the solid lines, and it was bent upwards by a distance of beta, and it maintains its thickness of t, and as you can see, the maximum deflections occur at pi over 2.